morning everyone. I'm Dr. Shalini Hanok, Associate Professor, Department of ECE, ATMA College of Engineering, Mysore. Today I'll be discussing about the experiment number 4 of Communication Lab of 22 Scheme 22 ECL 404. That is, design and plot the frequency response of pre-emphasis and de-emphasis circuit. Before going to pre-emphasis, what exactly is this pre-emphasis and de-emphasis? So emphasis is basically increasing something or giving special attention or providing some improvement in the signals or something like that. So in that we have different types of, we have pre-emphasis and de-emphasis. Pre-emphasis refers to boosting the relative amplitudes of the modulating voltage for higher audio frequencies from 2 to approximately 15 kilohertz. That's the audio frequency range. So it is basically making the signal more audible, that is providing more higher voltage as and when the frequency increases. De-emphasis is the exact opposite to the pre-emphasis. De-emphasis means attenuating those frequencies by the amount by which they are boosted. However, pre-emphasis is done at the transmitter and de-emphasis is done in the receiver. The purpose is to improve the signal to noise ratio for FM reception. A time constant of 75 microsecond is specific in the RC or LZ circuit for pre-emphasis and de-emphasis. This is basically we are going to use only two components in the circuit, that is a resistor and capacitor. So by the time whatever we want, T is equal to RC formula, using that formula for whatever time period we want the increment of signal or decrease of signal, that can be provided by specifying the values of resistors and capacitor. This is the basic circuit of pre-emphasis, where you have resistor, capacitor and two resistors and capacitor, then we have frequently modulated, and finally we will be getting the PM. It's a very simple circuit, wherein as and when the frequency increases, we are going to measure the voltage. Finally that voltage we are going to get it in terms of gain in dB, and we are going to plot the graph, frequency response graph. Pre-emphasis circuit at the transmitter, the modulated signal is passed through simple network. As I told you, it is only resistor and a capacitor circuit, which amplifies the higher frequency component more than the lower frequency components. The simplest form of such a circuit is a simple high pass filter of the type shown in the figure here, as I showed here. De-emphasis is just opposite to the pre-emphasis. We are going to just reverse the polarity of reverse the way the resistor and capacitor is connected, and since it is at the demodulator end, the emphasized signal will be de-emphasized, and we are going to get a reduction of gain, that is, as and when the frequency increases, the voltage decreases and also the gain decreases. This is the combined frequency response curve we are going to plot, wherein the y-axis is the amplitude of the signal and x-axis is the frequency. As and when the frequency increases in pre-emphasis, the voltage increases, that will increase the gain in dB. The opposite side, or the opposite will happen in de-emphasis, whereas and when the frequency increases, there will be a decrease of amplitude of the signal, and thus decreases the gain. So the point wherein the reduction or the increment starts is the frequency point, that is it is observed it is 2.1 kilohertz, and that is what we are going to achieve. This is the circuit which we are going to be implementing in the lab. We have the input signal and we have a capacitor. We can use 0.1 microfarad also for C1. In pre-emphasis, the above circuit is the circuit for pre-emphasis, this one, and we are going to use a capacitor here and a resistor here, this resistor here, and finally we will be getting an output, and we are going to keep the input voltage constant and vary the frequency and note down the value of output signal. And this is the de-emphasis circuit. See the way the capacitor and resistor connected are shifted, like the resistor from here to is shifted here and the capacitor from here to shifted here, and this is at the this is a circuit for de-emphasis at the demodulator end, wherein it is going to reduce the amplitude of the signal as and when the frequency increases. This is a tabular column. We are going to tabulate the values so that we can plot the frequency response. For pre-emphasis and de-emphasis, we have the same tabular column. We have different readings to be taken so that we get the graph in a better way. We have different frequencies, right from we'll start off with the 100 Hertz and we'll vary till kilohertz to 3-4 kilohertz, and we are going to note down the readings. Input voltage, usually it will be constant. Output voltage will definitely and has to change according to frequency of as we vary. And finally, using the output voltage and the input voltage, we are going to calculate the gain in dB. And this is the de-emphasis table. It is one and the same, what we did in pre-emphasis, but here we'll be getting the reduced voltage. Finally, gain will be reducing. This is the graph which I already shown, and usually we'll get this point at 2.1 kilohertz. That's within the audio range. Thank you. This is the theoretical aspect of the experiment. Practically, we will be doing in the lab, and we will show how the output is come. Thank you. We are going to see practically how pre-emphasis and de-emphasis circuits are connected and practically how we are achieved. So this is a circuit for pre-emphasis. We are using 7.8 kilo ohm resistor and 0.01 microfarad capacitor. So here we are getting the output. So the blue color line is the input applied. So we are applying the input voltage of 3 volts. So that is a constant input voltage we are going to keep throughout the variation of frequency. This is a tabular column. This is a tabular column for pre-emphasis, wherein we are going to keep V in as 3 volts continuously constant, and these are the different parameters we are going to note down, the number of iterations, and we have this frequency, output voltage, and we are going to calculate gain using 20 log V0 by Vin. So as and when we increase the frequency for pre-emphasis, the noise should reduce and we have to get a higher SNR ratio. So that's the reason the voltage should increase gradually as we increase the frequency. That we can see in the output. So for the constant Vin of 3 volts, so we are observing the voltage, we are varying the frequency. For a different frequency, the amplitude of the output voltage is increasing. You can observe that. Yellow color is the output voltage. So wherein now I am reducing the frequency, the voltage is reducing. Now I am increasing the frequency and the voltage is increasing. We are going to take on 10 readings and then we are going to plot on the graph. Now we are going to see practically how de-emphasis is done. In de-emphasis, we are going to have the resistor here 7.8K reverse way that we are connecting, and we are having a capacitor connected like this, which is 0.01 microfarad. This is a circuit, and now we are going to observe the output how we are going to get. For the constant voltage of, this is a constant voltage of 3 volts, we are going to note down this reading for the constant voltage of V in as 3 volts, we are going to note down different readings for different frequencies. So we have to get higher gain, and that's the reason we have to get lower gains. The gain has to reduce for de-emphasis. It's the reverse of your pre-emphasis. So the voltages will reduce gradually when we increase the frequency. That we can observe on the CRO, wherein again the blue line is the input voltage, 3 volts we have maintained it, and yellow line is the output voltage. So as and when we increase the frequency, the amplitude of the output voltage is decreasing. We can see that, we can observe that. So that's the gain will be less. It is decreasing for de-emphasis. As and when we decrease the frequency, the amplitude is increasing. When we increase the frequency, the amplitude of the output voltage is decreasing. This is the experiment of de-emphasis and pre-emphasis. Thank you.